So we'll start with our discussion of maths. This is basically maths for physics. Okay. So we'll start with calculus and basically try to understand what are the calculus tools and methods that we require for physics. So here, first of all, you have to understand what are we trying to do with calculus. So basically the idea is we want to measure the rate at which a quantity changes. The rate at which a quantity changes. For example, if you're going on a car journey from here to Mysore, obviously you are going to take some time to reach the destination, right?
Yes, sir.
Now, let's say the distance is 120 kilometers and you take 3 hours, and the average speed you can calculate is 40 kilometers per hour, but all the time you are not going at 40, right?
Yes, sir.
This was the average speed, but there is called instant speed, right? The difference between average speed and instantaneous speed is that instantaneous speed is the speed at the current moment, right? So that may or may not be equal to 40. It could be greater than, less than, or equal to 40. Right? Correct?
Yes.
So the point is that uh, if you want to know how fast the car is moving, then you have to do something else, which is basically look at the speedometer.
Yes, sir.
But what you will realize is that even the speedometer is actually not really giving us the instantaneous speed. When you look at a speedometer and it shows 51 kilometer per hour, what the speedometer is doing is not really doing calculus. It's not doing calculus to find the current speed. What it is doing is taking the average, speed over a small time interval. By a small time interval, it might be like half a second or whatever, right? It might be 1 second or half a second or 0.1 seconds, something like that. So what do I mean by that? Taking an average speed over a small time interval. Like what actually the speedometer is telling you is that in the last, like say 1 second, the car moved 10, 15 meters, right? So it is able to calculate how much the car is moving on a small time interval. No, this is small. Correct?
Yes, sir.
If you measured the whole thing, over 3 hours, the car had moved this much. So this is the average speed over 3 hours. Right? Whatever
Yes.
we got was the 40 was what? It was average speed over what time? It was over 3 hours, right?
Yes, sir.
But if you take average speed over only 1 second, then you will get 15 meter per second, which is roughly 54 kilometers per hour, right?
Yes, sir.
So the point is that even the car speedometer, what it actually tells us is that average speed over a 1 second period or a small time interval, right? Do you understand what I'm saying?
Yes, sir.
It doesn't really tell you what is the exact speed at a particular moment. There is a difference between that and what it has calculated here. This is the average speed over a time, let's say 9 o'clock and 0 seconds to 9 o'clock and 01 seconds. Between this time and this time, this is the average speed, right?
Yes, sir.
But do you think this is the same thing as the average actual speed at this moment, exact moment?
Sir, it's close, but it's not the same.
Right. So it is close, but it might not be the same, no? Because
Mm.
here also you're taking an average, no?
Mm.
So the point is that in all of the maths that you have learned, or all of the physics that you have learned so far, never have you actually calculated the exact rate of change of something. Exact rate of change at a certain moment. Every time you have calculated speed, you have done average speed, right?
Yes, sir.
Nobody has ever done an exact rate of or exact speed at a given time. That you have not found out, because that cannot be found out without calculus. Okay. So calculus is basically measuring like rates of change, exact rate at which some quantity changes as another thing changes. For example, let's say we have a situation like this. Uh, let's say the company was making some phones, and the money that it was making, which is known as revenue, the revenue was equal to 700 into n square plus 20n minus 3, where n is the number of phones it sold, right?
Mm.
Do you understand what I'm saying here?
Yes, sir.
This is the total money that the company was making, and it depends on the number of phones that the company is selling, right?
Mm. Yes, sir.
According to this equation, it depends on it. So obviously, like now, you want to maximize the revenue, right?
Yes, sir.
So what is the number of phones that you should sell at which the revenue is maximum? Or in order to make the question better, let's say this is the cost of making the phones. Okay.
Mm.
So obviously, what do you want to do as a company? You want to reduce the cost, right?
Yes, sir.
You want to keep the cost minimum, minimize the cost, right? That is a very practical challenge for any company. They want to minimize the cost and they want to maximize their revenue, right?
Yes, sir.
Then only you will make maximum profit, right?
Yes, sir.
So if the company knows that the cost depends on the number of phones sold according to this equation, the simple question would be, how many phones should the company make to keep the cost lowest, right?
Yes, sir.
You understand what I'm saying?
Yes, sir.
Basically, what is the value of n? What is the value of n so that C is minimum, right?
Yes, sir.
That is another type of question where calculus helps us do this very easy. How to find the particular value of n so that you can minimize the cost, right? So basically, problems involving maxima and minima, that is a major application of calculus. Calculus helps us solve such problems in a nice way, in an easy way, right?
Mm. Yes, sir.
Another example, another practical example of this maxima minima type of situation would be this. Suppose you have a can, Pepsi can or something, right? Correct.
Mm.
So Pepsi company is making these cans to hold some volume of liquid, right? Correct.
Yes.
Let's say the volume was fixed at 1 liter can. Suppose you are making a 1 liter can, right?
Mm.
The volume is fixed. What does the company want to do? It wants to make a cylinder such that it uses the least amount of metal, right? You understand what I'm saying?
Yes, sir.
If it uses more amount of metal, then what will happen? It will have more cost.
Mm.
So the company wants to design the shape and height and radius of the cylinder such that the volume is always 1 liter, but the metal that is used is lower, right?
Yes, sir.
The metal that will be used will be the surface area of the cylinder, right?
Yes, sir.
What is the surface area, total surface area of the cylinder?
2 pi RH.
No. You have
2 pi
forgotten
RH
about the
plus R square.
2 pi RH plus,
2 pi R square.
correct. That is the total surface area of the cylinder. And your job is, if volume is equal to pi r square h is equal to 1, this equation is always true, has to be true, right?
Hmm.
Has to be true. Accordingly, what should be the radius and height of my cylinder such that surface area is minimized, right?
Hmm.
Do you understand that this is like a really practical problem?
Yes, sir.
You have any company has to solve this problem, otherwise they will be you wasting their money, right?
Hmm.
So this is again a place where calculus will tell you the answer. Otherwise, like you can think of whatever you want to do, but you'll not get some easy answers
Hmm.
because this part has to always be true while you have to reduce this. So one thing you can do is h can be written as 1 by 2 pi r square, right?
Yes, sir.
And surface area, in the surface area, I can instead of h, I can put that, right? 2 pi r into, instead of h, I will put 1 by 2 pi r square, right?
Yes, sir. 1
Correct.
by pi R square.
So this will become 1 by r plus 2 pi r square, right?
Sir,
Correct.
1 by pi R square, right?
How pi r square?
Sir, sir, volume is pi
Oh,
R
ha,
square
1
H,
by
right?
pi r square, right? 1 by pi r square, correct. So it will become basically 2 by r, right?
Yes, sir.
So your surface area is now looking like 2 by r plus 2 pi r square, and your job is to get the minimum value of this, right?
Yes, sir.
So basically you have to find the radius at which this is minimized, correct?
Yes, sir.
Do you know any way to try to solve this? Anything that you can think?
Sir, you can draw the graph of R versus this and find the minimum location.
Draw the graph of what?
Draw the
Surface area
graph of,
versus r.
yes, sir.
But the graph of this will be annoying to draw, no? How will you exactly know where minimum happens? You understand that it will be annoying to draw the graph here?
Yes, sir.
It will be weird, no? Like it's not easy.
Ah,
And even if you draw the graph, you'll have to know exactly what point, like where minimum comes, right?
yes, sir.
Any other thing? Any other ideas?
So you can use calculus.
Oh, calculus though we can use definitely, but calculus we don't know right now.
Hmm.
Can you use anything from algebra to try to figure out when the minimum will happen? Like, have you heard of something called AMGM inequality?
Oh, yes, sir. Yes, sir.
What is that?
Sir, arithmetic mean of any numbers is always greater than equal to geometric mean.
If there are two positive numbers A and B, what is the arithmetic mean of A and B?
A plus B by 2.
Is always greater than equal to what is the geometric mean?
Root AB.
Right. So this inequality is also true for three numbers if you have, right?
Yes, sir.
You can say arithmetic mean of three numbers will be A plus B plus C by 3 and greater than equal to geometric mean which will be cube root of ABC, right?
Hmm.
Here, if you do A and GM of these two numbers, it won't work out because in the geometric mean there will be still root of R will be left over. Right?
Yes, sir.
Do you understand what I'm saying?
Yes, sir.
If you just take the two numbers, you will not get a nice thing, right? But what you can say is I can write this as 1 by r plus 1 by r plus 2 pi r square. Right? And now think of this as a, b, and c, right?
Yes, sir.
So you will say a plus b plus c by 3. So 1 by r plus 1 by r plus 2 pi r square by 3 is greater than equal to cube root of 1 by r times 1 by r times 2 pi r square, right?
Yes, sir.
Correct? By the A and GM inequality, right?
Yes, sir.
Notice that because we have split the 2 by r into two r terms, you are cancelling the r and r square. Right?
Yes, sir.
So you're getting that this thing is greater than equal to 3 times cube root of 2 pi.
Yes, sir.
So surface area should be greater than equal to this, right?
Yes, sir.
So the minimum value of surface area is 3 times cube root of 2 pi, right?
Yes, sir.
And AMGM inequality is equal. The equal case happens in AMGM when the quantities themselves are equal, right?
Yes, sir.
The equality case will happen when A is equal to B is equal to C, right?
Yes, sir.
So here if surface area has to be equal to this, 1 by R should be equal to 1 by R should be equal to this, right?
Yes, sir.
You can say 1 by R is equal to 2 pi R square. You get R cube is equal to 1 by 2 pi. You get R is equal to 1 by cube root of 2 pi, right?
Yes, sir.
It is at this radius 1 by cube root of 2 pi when surface area will become equal to this, which is the minimum possible surface area, right?
Yes, sir.
And if you know the radius, you can find the h by putting it in this, right?
Yes, sir.
So basically, in this particular problem, there was a trick method, which is the ANGM method by which we were able to get the answer. But all the time, obviously, it will not work. Here, the function was such that we were able to apply AMGM by splitting it and getting it, right? But most of the time, it won't be possible to apply AMGM because the quantities themselves won't be positive always, right?
Yes, sir.
AMGM can only work on positive quantities, right? Because you have a root away thing. If there is negative, it will become not real.
Yes, sir.
So the point is that here, since my quantities radius is always positive, this is also positive, everything was positive, so you're able to apply AMGM. Not always that will work. So in general, the best way to do such questions is by calculus. Okay. In
Yes.
certain specific situations, we might be able to use things from algebra like ANGM inequality and so on, right? But that is not a general method because it won't work in all the cases, right? The
Yes.
calculus method will always work. And so far, whatever examples I have given you are just to show you that it is super important. Calculus is very powerful and it is very important for you to understand it really well, right? So
Yes.
now what we will do is we will get to the basics of it. The first concept that you have to understand here is what is a function. What is a function? So let's think about it. Or have you heard of this term function?
Yes, sir.
What is it?
So it's basically a way of producing a specific value given one value. It
Right.
produces
So
specific other value. Yeah.
have you seen this thing?
Yes.
How do you read this?
Y equals f of x.
Y is a function of x, right? Y is equal to f of x. So
Yes,
what
sir.
is the meaning of y here and x here?
So given a value of x, it will produce a unique value of y.
Okay, so this is known as the input, right?
Yes, sir.
And this is the output, right? Output of the function, correct?
Yes, sir.
We can also call x as the independent variable, okay? And we can call y as the dependent variable. Why is y a dependent variable?
So
Because the
because,
value of y depends on the value of x, right?
yes, sir.
But x is independent because we can choose whatever input we want to give to the function, right?
Yes, sir.
Obviously, you should realize that input comes first and input decides what the output is, right? Like input is like the cause and output is like the effect, right? Correct?
Yes, sir.
Okay. So a function basically is a relationship between two sets of numbers. Like let's say we draw two sets. This is the set A, this is the set B. Set A has some values like this, maybe 1, 2, 3, 4. And set B has some other numbers here. This is let's say 2, 4, 6, 8. And now let's say we have connected 1 to 2, 2 to 4, 3 to 6, and 4 to 8, right?
Mm.
So basically this notation or this diagram is telling us that 1 is linked to 2. This is known as the image of 1, right? And
Yes.
this one is known as the pre-image of 2. Do you understand what I'm saying?
Yes, sir.
1 is basically the input and 2 is the output, right?
Yes.
Similarly, 2 is the input, 4 is the output. So 4 is the image of 2 and 2 is the pre-image of 4, right?
Yes, sir.
And similarly for these two also. The set of inputs, set of all possible inputs to a function, to f of x, which is in this case it is the set A, is known as the domain of the function. Okay,
Yes, sir.
the set of inputs is known as the domain of the function. The B set is known as the codomain of the function. Codomain set.
Mm.
B set is known as the codomain set, and it is the set of possible outputs, right?
Yes.
So what you need to think of is the function as a machine. Think of the function as a machine. It takes some input, which is the x, and it gives some output, which is f of x. This function is f function, right? This is the output, correct?
Yes, sir.
So the set of inputs is your A set, and it's called the domain. So all the possible inputs to this function will come in the domain set, right? And the set of outputs, set of possible outputs, will come under the set called B, which is called codomain. Are you understanding what I'm saying?
Yes, sir.
Okay. Now, some important things you need to know about functions. There are couple of rules. Like suppose you have drawn a figure like this: A, B, C, D, 1, 2, 3, 4, 5, 6. Okay. This
Yes.
is set A, this is set B. And let's describe the function by drawing the arrows connecting the inputs and the outputs. Let's say this is my diagram. Okay. So here we will say that this is not a function. Why are we saying that this is not a function?
So because all the elements in A are not mapped
Hmm.
to B.
Because D has no image, right?
Yes.
Correct? So first rule for function is all elements of domain should have an image, right?
Yes, sir.
Why does all elements of domain have to have an image? Why are we made this rule? Why can't we say this is also a function?
So because you have defined a domain as the set of all inputs.
We said it is a set of possible inputs, right? But why can't we say that, okay, this input has no output? The reason is because if you think of a machine, that is not a very good machine. No? Sometimes sometimes it gives output, sometimes it gives nothing.
Mm.
You understand?
Yes, sir.
It gives output sometimes, and some inputs it will give nothing. So that will not be a very useful machine if you want to use it in some purpose, right? Because
Mm.
you never know when you will not get anything.
Yes,
You
sir.
understand what I'm saying?
Yes, sir.
Like it might be working and then you are expecting it to work and it's not going to give anything. So you don't know whether you have to wait for some time to get an output or whether you abandon the thing, right?
Yes, sir.
So that's a commonsensical rule for why all elements of the domain should have an image, because it's not going to be a useful function if some elements have no output. Basically, it's not even called a function. Okay.
Yes,
Then
sir.
the second rule is, suppose B was connected to 5 also, right? Then also it's not a function. Not a function because B has two different images, right? Notice that here the B is connected to 2 and B is also connected to 5.
Mm.
So same input cannot have multiple outputs, or single input cannot have multiple images. You understand?
Yes, sir.
Because that machine is also weird, because if you input B, sometimes you get 2 and sometimes you get 5. So you can't really predict what is going to come out for B, right?
Yes, sir.
So that is not a useful machine again, so that we don't call such things as a function. So that is not allowed. Although it is okay for this to happen. Suppose D was connected to 3 and C was also connected to 3. That is completely fine. This is a function. Okay.
Mm.
Here what has happened is two different inputs have the same output. Multiple inputs can have the same image. Do you understand what I'm saying?
Yes, sir.
So that is totally allowed. So what are the two rules that have to be followed for a function? All the elements of the domain should have an image, right?
Mm.
Also, a single element in the domain cannot have multiple images, right?
Yes, sir.
These are the two rules for it to be a function. And notice one more thing. We are calling this a function. And notice that some of the elements here have no connection in A, right? They
Yes,
don't
sir.
have a pre-image, right?
Yes, sir.
But that is not a problem. It is okay for that to happen. It's not necessary that everything in B has to have a pre-image in it. Okay. But
Yes.
if you recall, it was necessary that everything in A has to have an image, right?
Yes, sir.
Are you understanding what I'm saying?
Yes, sir.
For example, I will give you the example of a function like this. Y is equal to x square. From set, this function is defined from set A to B, where A and B are the set of real numbers. You know what real numbers are, right?
Yes, sir.
Real numbers is the set of rational and irrational numbers. So
Yes.
basically, all the numbers that you have seen so far come under the criteria of real numbers. They are all real numbers.
Yes, sir.
Now, if you draw the set A is the set of all real numbers, and set B is also the set of all real numbers. Basically, any number that you can think of is part of this set, right?
Yes, sir.
Obviously, there are infinite elements in this set. Similarly, any number that you can think of is part of this set. right? There are
Yes, sir.
infinite numbers in that set also, correct?
Hmm.
Now, if I want to draw the function diagram, obviously the function was y is equal to x squared. So 1 should be linked to 1, minus 3 should be linked to 9 somewhere, right?
Hmm.
5 should be linked to 25, and root 2 should be linked to 2, and so on, right?
Yes, sir.
For all the real numbers, you will find its counterpart square of that, and you will connect it to this, right?
Yes, sir.
So this is an example of a function y is equal to x square. Notice that every real number will have some image, right?
Yes, sir.
And a single number in the set can only have one perfect square, one square, right?
Yes, sir.
The square of all of the numbers is going to be unique. It will not have two different possible squares, right?
Hmm. Yes,
So
sir.
this is a proper function. And now we'll come to understand what is the meaning of the terms domain, codomain, and range. What do I mean by all this? So domain is basically your set of all the inputs, right? So set A, right?
Hmm.
Codomain is the set of possible outputs, which is the whole set B. Okay.
Yes, sir.
And range is the set of actual outputs. This was what? Possible outputs.
Hmm.
You understand the difference between possible outputs and actual outputs?
Yes, sir.
Actual outputs will be 9, 25, 1, and 2, right? And so on.
Hmm.
It can never be minus 3,
Yes, it can never be.
because you are taking the square, so it can never take negative value, right?
Yes, sir.
But the B set had minus 3 also, no?
Yes, sir.
B set is the set of all possible outputs, whereas range is the set of the actual outputs.
So within minus 3, not a possible output.
No, I'm saying that f of A to B is defined between these two sets. There might be elements in this set which are not actual outputs.
Okay, yes, sir.
Don't worry about the word so much. The meaning is should be clear. You don't
Yeah.
have to fix on the possible or actual. What I'm
Hmm.
saying is B set is a larger set. Actual outputs are small part of it. Right?
Yes, sir.
Only the positive numbers in the set B can be in the range, right?
Yes, sir.
Whereas set B had negative elements also,
Hmm.
correct? So you will say that the codomain and range are connected like this. Range is a subset of codomain.
Hmm.
You understand what I'm saying?
Yes, sir.
Range is a subset of codomain. However, in some cases, it is possible that range could be equal to codomain also. It is possible that you could think of a function where actually all the elements of the codomain have a pre-image in the A set, right?
Hmm.
So in that case, we will say range is equal to codomain, and later we learned that that type of function is known as an onto function. Okay? So
Yes.
for now, you just need to remember what is the meaning of range, what is the meaning of codomain, and how they are different, right?
Yes.
I hope you are understanding so far what we have done.
Yes, sir.
So these are like basics of domain, range, and codomain. All of the terms you should be completely familiar with. Then we come to, suppose we have a question like this. I have made a table of values like this: 1, 2, 3, 4, 5, 6, and so on. This is X and this is Y. 3.1, 3.14, 3.141, 3.1415, 3.14159, and so on. This is the set of X and this is the set of Y, right?
Yes.
And these are linked like this, okay?
Yes.
Do you think Y is a function of X? Is Y a function of X?
Yes, sir.
Why?
Sir, because every element in X has a image in Y, and it is a unique image. It does not have two images.
How do you know that every element has an image in Y?
So these are the digits of pi, right?
Hmm.
Up. So whatever X is the set of natural numbers, and Y has infinitely many digits after the decimal point, and basically pi has infinitely many digits after the decimal point. So Y is basically, if X is a given value, Y is uh, pi up to X digits after the decimal point.
Correct. So, but can you write Y is a function of X? What is the relationship? That is impossible, almost impossible. The reason I'm saying that is impossible is because there is no pattern in pi.
Huh.
The infinitely many decimal digits in pi are not following any pattern because then pi is irrational. Irrational means non-terminating and non-repeating, right?
Yes, sir.
Since there is no pattern, it will be almost impossible for you to find a actual formula that connects y and x, right?
Yes, sir.
Because if you were able to figure out a formula, then that means you have a formula for predicting the digits of pi.
Hmm.
But you cannot predict the digits of pi. You have to get it by calculations through an infinite series and all, which we don't have to worry about right now. So what I'm saying is, even if the function is hard to define, hard to pin down or exactly define, right? Correct?
Yes, sir.
Like in this case, it is hard to define the function. No? How can you write it in terms of x, right?
Hmm.
Even then, this will be a correct function of x because it is satisfying the two conditions of being a function of x. What were the two conditions? That all the elements here have to have images, right?
Yes, sir.
And the second condition was that it cannot repeat, right? One single pre-image cannot have multiple images.
Yes, sir.
One single input cannot have two outputs, right? So here we are not doing that. We are going one-to-one correspondence, right? One digit after pi, two digits, three digits, four digits, and so on, right?
Yes,
So
sir.
because it satisfies the two conditions, this is a function, even though it's really hard to figure out what that function is. Like you cannot say y is equal to some 3 plus some x by something. We cannot figure out a formula for it.
Hmm.
Even though you cannot write it like that in a closed form, still this is a function of y and x.
Hmm.
Okay. So fine. So now that we understand what functions are, uh, what we have to learn is basically the concept of limits. Like in the maths class, I would have told you about different types of functions. Like at a later stage, you have to learn about like different types of functions. What are the meanings? Like one, many one, into, onto, and so on. But right now, my focus is not on the maths part of it, so I'm going a little ahead, right? Okay.
Hmm.
So we have understood what a function is. Now we can go to the concept of limits. Okay.
Yes, sir.
So what this means is, if you have y is equal to f of x, as x approaches a particular a, where a belongs to the domain of f, a must
Hmm.
belong in the domain of f, because obviously the function is only defined for those particular values of x, right?
Hmm.
Do you understand what I'm saying?
So, but x is not exactly equaling a, right? So,
Yes, it is not equaling a, but a is in the domain of f's, and in the neighborhood it is defined.
huh,
Like, for example, you have a here, let's say it is 1, and your f of x was x square minus 1 by x minus 1, right?
yes,
1 is not, we can remove this condition also. It doesn't even have to be in the domain. For example, here, 1 is not in the domain of the function. Why? Because if you put 1, it is becoming 0 by 0, right?
yes, sir,
1 is not an acceptable input to this function.
yes, sir,
So everything else is an acceptable input because everything else does not make the denominator 0, right?
yes, sir,
If the denominator is 0, then the function is not properly defined. Right?
hmm.
So
Yes, sir,
1 is not in the domain of the function, but any other point is in the domain. For example, if this is 0.5 and this is 0.9, this point, right? Obviously, any point closer to 1, like 0.99 is closer to 1, right?
yes, sir,
That is also a point where the function is defined, correct?
yes, sir,
So as you come closer to 1 from this side, you are approaching, x is approaching the values of 0.99, then 0.999, and so on. Okay.
hmm.
So as you approach the value of x, which is 1, you cannot actually be equal to 1 because 1 is not defined, but you can come close to it, right? As close as you want.
Yes, sir,
If you come close to the value of 1, the value of y will also become close to some constant, right? Because y was a function of x, right?
yes, sir,
And as x tends to a, y will tend to some quantity L, right?
yes, sir,
Now, this is a situation where we will say that the limit of x tends to a y, or limit of x tends to a f of x, is equal to L. Do you understand what I'm saying?
yes, sir,
So the idea of the limit is, if you come closer to a particular uh, point, you can come closer to it from both sides. You can come from closer to it from here, or you can come closer to it from the other side also, right?
hmm.
So if both of the times when it is coming closer to 1, the f of x value, f of x tends to some L value, both from the left when it is coming and from the right also, right?
Hmm.
That basically tells us that the function is approaching a limiting value, or limit of the function is L as x tends to a. Do you
Yes, sir,
understand what I'm saying?
yes,
For
sir,
example, if you have this f of x function here, we cannot directly put 1. So x is not equal to 1, which means now what we can do is cancel the factor x square minus 1 by x minus 1.
yes,
So you will get x plus 1 on top,
Yeah.
And as x tends to 1, f of x will tend to 2, right?
Yes.
So basically, that is the limit of the function as x tends to l. Because in the neighborhood of 1, the value of the function is getting closer and closer to 2, right?
Yes, sir.
Do you understand what I'm saying about limits?
Yes, sir.
In the neighborhood or nearby a particular point, what is the value that the function is taking? That value is called the limit of the function as x tends to that point, a or whatever.
Yes, sir.
Okay. So now you will see many situations of limits. So I'll show you by some graphs and all. For example, this graph is here and this graph is like this after that. At point here, x is equal to a. This is the graph of f of x versus x, okay? So what is happening is the function value is increasing, and then it drops and then goes like this, right?
Yes.
Now, here we will say that as x tends to a, f of x does not have a limit. What do we mean by that? What it means is that as you approach a from left hand side and from right hand side, right?
Mm.
As you approach a, the value of the function from the left hand side is becoming equal to, let's say, some y1, right?
Yes.
Whereas value, if you approach from this side, value of the function is coming equal to some other value y2, right?
Yes, sir.
So basically the idea is that from this side you are approaching a y1 and from this side you are approaching a y2. So that is going to be called that limit does not exist. Limit doesn't exist. The reason is you are getting different limits from both sides, right?
Yes.
You are getting basically on the left hand side you are getting the value of y1. Y1 is the limiting value of these x's.
Mm.
And if you go on the other side, the y is approaching this value, which is y2, which again is different from y1. So the two tendencies from left and right are not matching, right?
Mm.
They are tending to two different things. So we'll say limit does not exist. Okay.
But can't we say the limit from the right side is this and the limit from the left side is that?
But the limit from the right side and left side is different values.
Yes.
So
So
since they are
can't
not
we say
matching,
it's two separate limits?
we can say it is separate limits. We can call it as left hand limit and right hand limit. But that is a specific terminology. When you think of it in terms of physics and all, we will not be splitting into one-sided limits. We'll say, does limit as x tends to a f of x, what is the value of this? We will say it does not exist. Why? Because the two left-hand side and right-hand side tendencies are not matching. No?
Yes, sir.
However, we can say that limit of x tends to a minus f of x. A minus f of x means from below a, from this side, is equal to y1. And we can also say limit of x tends to a plus in that case, right?
Mm.
F of x, in that case, a plus, it is y2. By a plus, we mean you're coming from the positive side of a, from this side.
Mm. Yes, sir.
So we can say left hand and right hand limits exist, but LHL must be equal to RHL in order to say that this limit exists, the full limit. Are you understanding what I'm saying?
Yes, sir.
So the limit definition is that from both sides the function should tend to the same value. Then only you say limit exists. Okay. Now there are many standard ways to calculate limits. Uh, some ways are rationalizing the irrational parts, factorizing, cancelling factors. There is also the power series method. However, doing limit calculations is not the point, right? Okay. So right now we are learning just enough calculus to help us with the physics. Anyway, we'll go into much more detail of what limits are and how to calculate limits in different situations. But for now, it's not super important. What you need to know is what limits are. Okay. Once you understand limits, in the next session, what we'll be doing is we're starting the basic theory of derivatives. What is a derivative? And once we do derivatives, I will tell you some standard limits that you need to be aware of. And I will prove those standard limits for you. And after that, we'll see how to find the derivative of a function. Okay. There are several things still left: finding the derivative, how to use derivatives to get maxima, minima, which we started the class with, right? Then there is also, once you know this, what we can also think about is finding maxima, minima. That is another application. And later, when your differential calculus is, see, this is another application that we will learn about. Once differential calculus is done roughly, then we go to the integral calculus part. So far I'm not talked about integral calculus because our first priority is to understand this functions, limits, derivatives, and applications what example I gave you earlier, right?
Yes, sir.
Finding maxima and minima. That is one application.
Yes, sir.
Okay. What you need to do is again go through HCV, see what is being explained there for derivatives and stuff, and we will continue from this point in the next class. In the next class, we'll be working with the derivatives part only. So read up as much as you can. If there is not much in HCV in this chapter and you have to do more, then you should check out the maths NCRT book where limits and all is introduced. It will be in 11th grade, some part 1 or part 2. You have to see which chapter they are talking about functions and limits from the NCRT book. I'm just saying NCRT book right now because that is very easy. So you should be able to understand what is going on there. That's about it for now. We'll continue from this point.
Thank you, sir.
Have you made some notes and all, some important notes?
Yes, sir.
Make sure that you make notes and all. I have already recorded this class and I will put it on a drive which you can see later also. So all of the classes will be recorded. You can see them later.
Okay.
Right. And make sure that you have ordered the books that I told you, right?
Yes. Yes,
For
sir.
physics,
We've ordered.
there is only 2 plus 1. PYQ book you have ordered, no, for all three.
Yes, sir.
And for maths, there are 5 books and PYQ, right?
Yes, sir.
Which one have you bought? Arihant or Cengage?
So we currently have Cengage. We got it like Cengage.
All the 5 Cengage you have?
Yes, sir.
Okay, fine. So SL only you have ordered for
Yes,
maths.
sir. SL only we've ordered. Yeah.
Okay, fine. Next class also we'll continue with this only. We need to finish the basics of calculus before we can do physics. So this week mostly will be this week and next week will be mostly working on calculus, trying to finish as much as possible.
Yes, sir.
After that, we will split the classes and we'll do maths. When we do actual, the starting point of maths will be from trigonometry.
Hmm.
So till we finish calculus, we'll not be doing anything else. Once we do the basic calculus part, we'll split the classes. It will be physics class will be from chapter 3, maths class will be in trigonometry as a whole.
Okay, yes, sir.
To understand what I'm saying, no?
Yes, sir.
You have any doubts, any questions?
Sir, no doubts.
Fine, that's all for now.
Thank you, sir.